Welcome back to Algebra 1. We're going to continue multiplying monomials. The only thing is we're going to crank up the complexity a little bit, and with viewing and working these problems, you'll get a lot of really great experience. You'll get very good at this. So what if you have m squared times n, that's one of the monomials, multiplying times m times n to the fourth power. So we want to simplify this. We're multiplying these guys together. The only difference between this and the previous problems is that we have two variables. This is just a term, a monomial, and this is another term of another monomial. So when we multiply them, really what's happening is everything's being multiplied together. M squared times n times m times n to the fourth. So since everything's multiplied together, we look for the same base, and then we add the exponents. We have an m here and an m here. There's a first power, so we can add those together. M cubed, and then we have an n here and an n to the fourth. The bases are the same, so we add them together. 1 plus 4 is 5, n to the fifth power. So the answer is m cubed n to the fifth power. And that's really all you're doing. You're looking for the same bases and you're adding the exponents together. What if you have 4x to the fifth times negative 3x squared? You multiply the numbers. You can always do that. 4 times negative 3 is negative 12. And you have here an x to the fifth, so you have the same base as this. So these are basically the same base, and you can add these exponents. So you'll have x to the seventh power. 5 plus 2 is 7. So you have negative 12x to the seventh power. Let's crank things up just a little bit here. What if we have negative 3 times x times y cubed times negative 2 times x cubed times y, like this? First of all, you can multiply those numbers together. Negative 3 times negative 2, you have the negatives here, they're going to make positive 6. So you can always write that down. And then you look for the same bases. Here's an x, here's another x to the third. You can add the exponents here. 1 plus 3 is 4, so it'll be x to the fourth power. And then you have y cubed times y. So you can add those together. 3 plus 1 is 4, so y to the fourth power. So it's 6x to the fourth, y to the fourth. And that's the final answer. What if you had 5a squared b cubed times c times 2 times a times b to the fourth power times c squared? How would you handle that? So same thing, you can multiply the numbers. 5 times 2, right here, 5 times 2, give me 10. And everything's multiplied together. All this stuff is multiplied by all of this stuff. So since they're all multiplied together, we have a base of a and an a here. So 2 plus 1 is 3. A cubed. We have b cubed and b to the fourth, so same base. So it'll be b to the seventh. And then we have c and c squared, so it'll be c cubed. So it's 10 times a cubed, b seventh, c to the third power. What if we had, just cranking through this, negative x squared times y to the third times 3 times x y squared times a third term, negative 2 times x cubed times y. Now, it's easy to get confused when you have lots and lots of terms multiplied together, because now things start to run together. Instead of trying to handle all of it together, I always recommend that you break things down into simple things. So what I would recommend doing is multiply these first two first, get the result, and then multiply by the third one, which will always give you the right answer, and that way you're not trying to handle too many things at once. So we look here and we have negative 1 times 3. So that's going to give me negative 3. And then we have x squared and x, so we can add those exponents. It'll be x to the third power. And then we have y cubed and y squared. We can add those for y to the fifth power. So now I have negative 3, x to the third, y to the fifth. Now, I'm going to wrap that in parentheses, and now I'm going to multiply that by the negative 2x cubed y, because I know I still have to do that. And now I can look at my terms. I have negative 3 times negative 2, which is going to give me a positive 6. And then I look at my x's. Here's a base of x. 3 plus 3 is 6, so it'll be x to the sixth power. And then I have y to the fifth and y, so I can add those together, which is 5 plus 1 is 6, so y to the sixth power. So the answer is 6x to the sixth times y to the sixth power. All right, Not too bad. You just have to break it up. That's the easiest advice, or the best advice I can give you. Now, what if we have something over here like 2/3 t to the 4th power times 3/2 t to the 2nd power? All right, so there's lots of ways you can do it. I mean, some people are going to have different ways that they want to do it, but since you have fractions here, I think it's always better to kind of rewrite things a little bit. So the fractions here are multiplied by each other. They're the numbers. So instead of trying to do the fraction math all at the same time, rewrite that part. 2/3 times 3/2, and then we have the t to the 4th and the t squared multiplied, and the bases are the same, so we can add the exponents. It'll be 4 plus 2 is 6. So now all we have to do is the fraction multiplication. Now, there's a couple ways to handle it. I'm just kind of give you both. You can multiply the tops, and that will give you 6, and you can multiply the bottoms, and that will give you 6. So you'll have 6 over 6, which is just 1. So effectively, it's going to disappear. It's going to just be an invisible 1 there. But another way to handle it is what we've been talking about before. You know these are multiplied, so you can look at the top and the bottom. You see the same thing, a 2 in the top and the bottom. So you can cancel that with that, they're going to divide out and give you 1. But you also see a 3 in the top and a 3 in the bottom, so you can cancel those out because 3 divided by 3 is also 1. So they don't disappear, it's just everything's dividing away. And when you write it like that, then you know that all you have at the end of the day is t to the 6th power, because everything's divided out. So however you want to handle it is fine. The final answer is t to the 6th power. Now we're going to have one final problem in this section. What if we have 3p to the 3rd power times q times negative 5/6 times q to the 3rd times negative p to the 4th power? Now, I told you a long time ago in algebra, fractions were really important, and this is kind of why. You can't be scared of fractions. That's why I covered fractions so extensively beforehand. So what you need to do is, if you try to do all of this stuff together, like take the 3 times this, and then with this negative, and then try to do everything at once, I mean, you could get the right answer, but it's very ripe for problems. So what you need to do is focus on the first two first. Just do those. So the way you're going to handle it is multiply the 3 times this. So let's write it like this. Let's say 3 is going to be written as 3 over 1 because I'm going to multiply by the fraction negative 5/6. So those are numbers that are multiplied together. And then I start looking at terms. P cubed, and there is no p here, so there's nothing to add. Those are multiplied together. There's nothing to add there, so I just list him as p cubed. But then I also have a q and a q cubed, so I can add those, and that makes q to the 4th power. Okay, so to make it absolutely clear, let's enclose this in brackets because it's kind of the product of these terms here, and now let's multiply it by what we have to do here at the end, negative p to the 4th power. All right, now again, there's a couple of different ways you can do this over here, this fractional stuff over here. There's a couple of different ways you can do it. But for us, let's just go ahead and multiply the tops and the bottoms, okay? Like I say, there's different ways to do it, but let's just do this. So what we have is 3 times 5. Now don't forget there's a negative sign, so the answer is going to be negative. So it's going to be negative 15 on the top and 6 on the bottom because 1 times 6 is 6. And then we're going to have over here, now we're multiplying over here, we're going to have, well, let's just kind of keep it simple. We'll rewrite everything. P q to the 4th power, and then we're going to multiply this as negative p to the 4th power. All right, so now what you have is a negative times a negative, which is going to give you positive. So that's what's going to be. It's going to be positive. Now we need to simplify this fraction. 15 over 6. What can we divide the top and bottom by to simplify the fraction? Well, we know that 3 goes into both, so we'll divide by 3, and that's going to give you 15 divided by 3 is 5, 6 divided by 3 is 2. So really the fraction 15 over 6 is really 5/2. So let's go down here and write that. The negative here times this negative is going to give you positive. So basically the negative sign disappears. You'll have 5/2, and then we look for common terms. P cubed, p to the 4th power. You can add those, giving you p to the 7th power. And then we have q to the 4th, but nothing over there, so there's nothing to add to it. It'll be q to the 4th power. So the answer is 5/2 p to the 7th power, q to the fourth power. So again, not rocket science, but you really do need to make sure you understand how to add these or how to multiply fractions together, how to simplify fractions, which we did here to get the good result. And then you have to remember things like negative times negative gives you positive. So there's a lot of little chances for mistakes in algebra, and so the best thing you can do is do one little step at a time to make sure to minimize the chance for errors, and then go back and check your work. So follow me on to the next section, and we'll continue learning about monomials and how to deal with them in algebra.